Hey, this is Brad, and one of the coolest things that has just been happened is the very first photo of our supermassive black hole in our galaxy in the Milky Way. Now, look, I was so excited. I was up all night watching the press conference as this image was released, because this is the first time we've seen a black hole in our galaxy. Now, we've seen another galaxy's black hole, a supermassive black hole, in what we call M87. Now, the M87 black hole is much bigger than our Milky Way and also much further away. But that was a huge achievement when that very first image of any black hole was ever released. And we've known that there's been a supermassive black hole in our galaxy for quite a long time. In fact, one of the coolest experiments, in fact, this was the subject of the Nobel Prize recently, was monitoring the stars near the center of our galaxy, near a point we call Sagittarius A star. And so Sagittarius A star is the name of our supermassive black hole, and they've been monitoring these stars orbiting around it. And what they saw is as the stars got closer to this area, they zipped around and they spun around and got flung out. They were able to see that there was something with a massive amount of mass and therefore a massive amount of gravity changing the orbits of these stars. And so using telescopes in Hawaii and Chile, observing them for over about 20 years, they were able to see this effect. And so by measuring the orbits of the stars, they can calculate the force needed, and force here is gravity, and once you have gravity, you have mass. And so they're able to figure out it weighed about 4 million times the mass of our sun. That was this black hole in the center of our galaxy. But we didn't have an image of it. So on comes the Event Horizon Telescope project. Now, this collaboration is pretty amazing. Firstly, the fact that they were able to convince people, let's use all of your telescopes, give us some money and support so we can image nothing, right? The goal here was to image nothing. Because when we look at these images, we're looking at the black hole's silhouette or shadow, and the orangey red bit is stars and gas that has been ripped apart, super speeded and superheated, spinning around very fast of this black hole. Now, the event horizon is the boundary where not even light can escape. So how do you observe this boundary? So the way this whole project worked is they had a bunch of telescopes, about a dozen, up and down the US, the North America, South America, and kind of into Antarctica. And the idea here is if you have all of these telescopes in about the same longitude, so up and down, they can observe the same point in space. Now, everyone can essentially see the center of our galaxy. So they can all observe at the same time, and it actually has to be down to a fraction of a second at the same time. It's not even okay if it's like within a minute. It has to be the same fraction of a second. This is why there was no telescopes in Australia. And so what you're doing is taking all of these telescopes and using it like a really big telescope, almost the size of the Earth. So what you're gaining is essentially the resolution. So if you're to spread out your eyes really far apart, you could resolve something really well. It doesn't mean you can see more light, but you can make it out clearer. So by having this really big telescope, it's like they had this mirror the size of the Earth with just a little bit of light collected at a few points. They didn't need a lot more sensitivity or power to see it, they just needed clarity. And by observing it across these latitudes and by waiting for the Earth to spin, you can actually then image part around of the black hole. So this is a huge technological achievement. Again, the fact that they're able to pull off imaging a black hole, something that we've known for decades, but we're finally able to see, is why scientists like me have just been over the moon, over the black hole. In the midst of all this exciting black hole news, we also saw scientists grow plants in actual moon dirt. Now, this is a huge achievement and a very important one as we aim to send humans back to the moon. Now, people have tried to grow plants in simulated or synthetic moon dirt lots of times. What they do is they measure the composition of moon dirt, they put the rough ratio of ingredients and elements into this fake dirt, and then grow, and we've shown that this can happen. But what this team did that was very different was they took actual moon dirt gathered from some of the Apollo missions like 11, 12, and 17. So tons of moon dirt and rocks were collected on them. NASA gave some of them to these scientists. So most of these samples are locked away to prevent contamination. So they took some of these dirt samples out and put them in little vials and then grew a type of crest in the actual moon dirt and then in some of this synthetic or created moon dirt. And what they saw was, yep, we can grow it in the fake or the created moon dirt, but they actually grew in real moon dirt with nothing changed really to it. Now, the plants in the actual moon dirt, which is on the right of this image, are smaller than the ones on the left, and that's in synthetic. And this is actually really important because everyone has assumed it's going to be relatively straightforward and viable to grow plants on the moon. But what this team has shown is, yeah, we can do it, but the plants are really small. They took a lot longer to grow. So yes, it can be done, but now that we know it can be done in actual moon dirt, now they can start adding certain compositions, nutrients, fertilizer, that sort of thing to grow plant growth. So it's telling us a lot about there's still stuff in the actual moon soil that we can't replicate in the lab, but we can still grow plants on the moon, something that's going to be super important as astronauts get back. So I hope you like hearing about moon dirt, plant growing excitement, and seeing our first black hole in the Milky Way. Make sure to subscribe to YouTube to keep up to date and help me make some more awesome space videos.